Okay, this is the P1 paper from October 2023. This is question number 9, which fills the entire screen here, but let's just have a look at the first part of it. It's a radians question. We're going to be working out the lengths of arcs and areas of sectors, etc. Give you time just to have a quick read through of all of that. But what I can tell you, having reread it already, is that those two pieces of information are not on the diagram. The length of the arc PS is 0.72. So this is this length here. That's 0.72. And it also tells me that the angle of POS, which is that angle in there, is given by 0.6. So if I look at that circle there then, the white circle there, I can see that it's asked me to find the length of OP. So it's asking me to find the radius here. Well, yeah, that's going to be very straightforward because I can always use that the length of an arc is r theta. And if I'm looking at that, there's r, there's theta, there's the length of the arc. So that's going to be very straightforward for the first part. So let's just get rid of some of the writing there. Let's do that then, part A. So simply quote that L equals r theta and then put in the information that we have. 0.72 is equal to r times 0.6. So r is going to be 0.72 divided by 0.6. And we know what it is because they've asked me to prove it. That works out to be equal to 1.2 meters. So that's the radius. I'm not going to put it in because I haven't got space on the diagram. But that's the radius of that circle there. It then says for part B, given also that the target area of this sort of like javelin or discus thing is 90 square meters and length PQ is X, can I show that quadratic? So PQ is this length all the way here. And it's telling me now that this area of this grey part is equal to 90 square meters. Well, I know that the area of the grey part is going to be, let's see if I can do this clearly enough for you to be able to see it, but that sector there, the sector with the centre O, OQR, if you want to call it that, that sector there, if I work that out, which will be half r squared theta, but it'll be half r squared theta where the radius of that sector is going to be my 1.2 plus x, that length there. So half r squared theta will give me the sector, and then if I take away this tiny little sector in here, which is half r squared theta again, half r squared theta with the big R minus half r squared with the smaller r there will give me the area 90 square meters. So by doing that, I'm pretty sure that the quadratic that they're asking for will come out. So let's try and be clear. Area of sector, and I'm going to call the small one OPS, and then I'm going to call the big one OQP when I'm doing it. Sorry, OQR when I'm doing it. So to make it clear to the examiner, area of sector OPS, that's half r squared theta. And then obviously be really clear with what I'm putting in here, half. That's with the 1.2 squared and 0.6, and then I can work out what the answer to that is. I'll do that in a second. Then the area of sector, the larger one, OQR, is again half r squared theta, which is half, well this time the radius for that is 1.2 plus x squared. Theta stays the same. So if I do this one minus this one, that's going to equal to 90. So that's exactly what I'm going to do. I'm going to say, I'm not going to try and calculate anything yet. I'm going to say, so area required is equal to a half 1.2 plus x squared 0.6 minus a half and then 1.2 squared 0.6 is equal to 90. And then what I would need to do to get to that quadratic. So don't worry about getting to the quadratic yet. Just tidy everything up first of all. So I'm going to say, as I'm looking at this, let's multiply everything by 2 to start off with. So I'm going to say 1.2 plus x all squared times 0.6 minus 1.2 squared times 0.6 is equal to 180. So that's got rid of the fraction out of it. Then let's multiply out this bracket here, 1.2 plus x all squared. I'm just going to move that around slightly. I'm going to call that x squared plus, now you can do this slowly, okay, but it's x squared plus 2.4x plus 1.2 squared. That multiplied by 0.6 minus 1.2 squared multiplied by 0.6 is equal to 180. And then if I look at this part in here and this part in here, they're actually cancelling each other out. So when I'm doing that, I'm going to get 0.6 x squared plus 1.44 x, and then I'm going to say plus 1.2 squared 0.6 minus 1.2 squared 0.6 is equal to 180. Those two will just cancel each other out. It's entirely up to you how much of this stuff, you know, if you're simplifying this, you can simplify it at your own pace here. I'm just aware of the fact that there's a proof that I'm trying to make, so I didn't want to do it too quickly. I'm now at the stage where 0.6 x squared plus 1.44x is equal to 180. And then what I can do is just multiply that by, what am I trying to get that to be? 5. So, well, let's just do it slowly. I was going to do it slowly before. So if I just multiplied it by 100, I just want to get rid of the 1.44. I want to get rid of all the, so that would be 60x squared plus 144x is equal to 180. And then divide everything by 12. And I'm only doing that because I can see that the answer in the book is, the answer that I'm looking for has got 5x squared in it. So that's why I did that part there. Take less steps than I'm doing here to get to the stage where 5x squared plus 12x minus 1500 is equal to 0. That when I got to that bit there, yeah, I was trying to get to that answer there. So I can see, thankfully at least I haven't made any mistakes with my algebra. It's quite nice to have a show that question because it does afford us a little bit of confidence in the middle of a question. And then the last part says, right, hence calculate the total perimeter of this grey shape here. So let's just go back and look at that then. So if I want this total perimeter then, what I want is 0.72, which I've already got, x, which is going to be the solution of that quadratic in a second, 2 of those, and then I'm also going to want QR here, and QR is just r theta, but it's r theta where r is actually all of that length there. So now I've explained it to you, got to go and explain it to the examiner as well. So for part C here, again, it's entirely up to you which order you do this in. I'm going to work out what x is first of all. So we had 5x squared plus 12x minus 1500 is equal to 0. Now, you might spend some time trying to factorise it. I normally would have a go at trying to factorise it. If it's something like that, we're just think, cool, that could take me a little bit of time. There's absolutely no problem with sticking into quadratic formula. I'm going to do that for this one, just to show you that it can be done that way. Square root of, and then we'd have 12 squared minus 4 lots of 5 lots of 1500. Obviously the minus and the minus is going to make that a plus. All over 10, and I'm looking for 2 answers and only one of them is going to be a positive value. So when I do that and I put that in, I'll actually tell you just because I've looked at the examiner's report for this one, it works out to be this really nasty value here. So it didn't factorise, which I'm going to call 16.2, But then all you've got to do is to be aware of that. Even if I'm calling it 16.2, I'll use the full number on my calculator here. When we get our final answer, depending on how accurate you've been, it can affect the accuracy of that answer. And I'll talk about that when I get that far. But I'm going to call it 16.2 just for the last little bit of the video. So I've got that. Remember what I just said. I want the arc length, that larger arc length QR. Well, that's going to be L equals R theta. So that's going to be L equals X plus 1.2 times 0.6. And obviously now we've got 16.2 plus 1.2 all times by 0.6, which I'm going to call 10.44. And so my perimeter then is going to be equal to X plus 0.72 plus 10.44, which for me then works out to be 16.2 plus 16.2 plus 0.72 plus 10.44, which I then made 43.56. Now, obviously, if you look at that, if it had been just slightly less than that, 43.56 rounds up to 44 square meters. What they've done in the answer scheme is they've actually given you 43 or 44. So I assume that they've allowed for the fact that some people will be, using whole values and some people will have used values that have been corrected. But my advice is to basically keep the number in your calculator right till the very end, and then just simplify, then just do it to the right number of decimal places or significant figures at the very, very end here. But we don't need to worry too much because they've allowed for that in terms of the answer scheme and what they've said that they will accept as a reasonable answer. Apart from the accuracy part of that, that should be relatively straightforward to you. Just make all your work nice and clear. Hopefully that all makes sense.